Hello and welcome to Sir Optics Academy. In today's video, we'll be looking at alkanes, also called paraffins. Alkanes are saturated hydrocarbons that forms a homologous series with the general molecular formula CnH2n plus 2 CnH2n plus 2. Now, all alkanes forms a homologous series with this molecular formula. Now, a homologous series in the sense that a successive member will differ from the previous one by CH2. Now, for this general molecular formula, N here represents the number of carbon atoms. N in this formula is equal to the number of carbon atoms. For the first member of the alkanes, our N will be equal to 1. Now, by inputting 1 in the formula, we will have C1, which is the same as C, H2 times 1, which is 2, plus 2, which is 4. Now, for the first member of the alkanes, it have this molecular formula, CH4. Now, going with the second member of the alkane, we'll have our N is equal to 2. Now, inputting that in the formula, you have C2H6 because 2 times 2, 4 plus 6 plus 2 will give you 6. Now, alkanes have the characteristic ending ANE. ANE. This is the characteristic ending of all alkanes. Now, the first 4 members of alkanes are called by their trivial names, while the others are derived from their Latin prefixes, which indicates the number of carbon atoms. Now, let's make a table and show the first 10 members of the alkane family with their molecular formula and their IUPAC name. Now, when N is equal to 1, we'll input 1 in the formula and we'll have CH4. Now, this is called methane, which is the first member of the alkane family. When our N, the number of carbon, is 2, we'll have C2H6. So this will be ethane, which is the second member of the alkane family. When our N is equal to 3, we'll have C3H8, which is the third member of the alkane family called propane. When our N is equal to 4, we'll have C4H10, which is the fourth member of the alkane family called butane. Now, here is a table showing the first 10 members of the alkane family with their molecular formula and the IUPAC name. Now, you can see that for all the 10 members of the alkane family, they all have the characteristic ending ANE. So now, this is what indicates that a particular IUPAC name given for a particular compound is an alkane. Now, let's look at the structure of alkanes. The structures of alkanes. In all organic compounds, the simplest of them all is methane. Methane is the simplest organic compound and it is an alkane. Now, from our introduction, we said natural gases are major components of methane. Now, they are formed as a result of anaerobic um, reaction in organic compounds in the earth crust. Now, for this first member of alkane, which is the simplest in organic structures, we have a carbon atom that is covalently bonded to 4 other hydrogen atoms. Now, this particular carbon is sp3 hybridized. sp3 hybridized. So, as a result of that, this particular carbon is non-planar. It is non-planar. Now, the bond found in this particular compound is known as the covalent bond. A covalent bond. That is why I said this particular carbon is covalently bonded to 4 other hydrogen atoms. Now, the bond length of organic compounds is 154 nanometers. 154 nanometers, and it is the longest bond found in organic compounds. The bond found in alkanes is 154 nanometer, and it is the longest bond found in all organic compounds. Now, as a result of the bond length, this carbon, a carbon in alkane, is bonded to a hydrogen or another carbon at an angle of 109.5 degrees. Now, going by the 3D structure of this particular molecule, we'll have the structure drawn this way. Now, this is the structure of methane, a carbon that is covalently bonded to 4 other hydrogen atoms and with a bond length of 154 nanometers at a bond angle of 109.5 degrees. Now, for ethane, this is the structure of ethane. Now, this is the 3D structure, 3-dimensional structures of alkanes. And then this structure is non-planar at an angle of 109.5 degrees with a bond length of 154 nanometers. Now, all alkanes are tetrahedral in shape. Alkanes are tetrahedral in shape with a hybridization of sp3. Now, for conveniences in the study of organic compounds, the structures of organic compounds are not drawn using the 3D format, but instead they are drawn using the 2D format. Now, in that format, each covalent bond is represented with a hyphen. Now, this is what I'm trying to say. This is what I'm trying to say. Now, let's draw the structure of methane. For methane, each covalent bond drawn using a hyphen. Now, this is the 2D structures of organic of alkanes, two-dimensional structures of alkane. Now, in this case, we have methane. Also, for ethane, it is drawn the same way. Each covalent bond linked using a hyphen. Now, this is the 2D structure of ethane. So, the 2D structures of alkane are planar, unlike the 3D structures that are on non-planar. So, organic compounds can also be drawn using the electron dot format. Electron dot format. Now, in this case, you have this is how it is being drawn. Now, the dot structures linking this, and then lastly linking this. Now, take note of this. Each covalent bond in an organic compound contains two lone electrons. Two lone electrons. Now, this particular covalent bond contains one electron, that of carbon, and one electron, that of hydrogen. Now, we already know that covalent bonds are bonds that are formed by sharing of pairs of electrons. That is far from ionic bonds, because we know that ionic bonds are formed due to transfer of electrons from metallic elements or metallic compounds to non-metallic compounds. But then in covalent bond, there is a sharing of a pair of electrons. So you can draw alkanes using the 2D structure or the electron dot format. Already, the covalent bond indicates that there is a pair of electrons between the two atoms that are linking together. But then if you are using the electron dot format, you show the two electrons that are being shared by the two atoms or two elements that are being linked together. Now, take note that carbon always forms 4 bonds except if it is an ion. Now, carbon is found on group 4 of the periodic table. For that, carbon has 4 electrons in its outermost shell. So it needs 4 more electrons to complete its outermost shell. For that, let's draw this is the electronic configuration of carbon with an atomic number of 6. Now, we know that the first shell contains only 2 electrons, while the second shell contains 8 electrons. But instead, carbon forms only 4 electrons in its outermost shell. In that case, it needs 4 more electrons to complete its outermost shell. That is why carbon forms just 4 bonds, not more than 4 or not less than 4, except if it is an ion. Now, when carbon links together with other atoms using a covalent bond, there is a sharing of a pair of electrons which make carbon to be complete. Now, this is how you link electrons using the electron dot format. This is how you link electrons using dot format. Now, with all this being said, let's look at a little subtopic in the study of alkanes. Let's look at alkyl groups. Now, let's look at alkyl groups. Alkyl groups are formed when there is a removal of one hydrogen atom in alkanes. Now, we know that alkanes have the general molecular formula CnH2n plus 2. Now, with the removal of one hydrogen atom, we'll have the molecular formula as CnH2n plus 1. Now, this is the molecular formula of alkyl groups, of all alkyls. Now, the first member of alkanes is CH4. Now, with the removal of one hydrogen from CH4, we'll have CH3. Now, this is an alkyl and the first member of the alkyl groups. Now, alkyls are named by removing the ANE and then replacing it with YL in the corresponding alkyl. Now, for this, we have methane as an alkane. Removing the ANE and replacing it with YL, we'll have methyl, which is the first member of the alkyl groups. Also, the second member of alkanes is C2H6, which is ethane. Now, when you remove one hydrogen from there, you're going to have C2H5. Now, replacing the ANE with in alkanes with YL, you're going to have ethyl, which is another group of alkyl group. So this is how the chain continues. All alkyls are represented with a capital letter R. Now, in your study of organic chemistry, when you come across, let's say for instance, you come across something like this, R linking to X. X here indicates the halogen, while R here indicates the alkyl groups. So the alkyl group can be a methyl, an ethyl, a propyl, a butyl, and the rest. So before we end the class, let's look at the classes of carbon atoms and then look at one practice question and then we'll call it a day. Let's look at the classes of carbon atoms. Now, in the study of organic chemistry, there are 4 classes of carbon atoms. Number 1 of it is a primary carbon. A primary carbon. A primary carbon is also called a 1-degree carbon. A 1-degree carbon. Now, this is a carbon that is linking to just one carbon atom in the parent chain. Now, this connection makes it possible for that particular carbon, which is a primary carbon, to be connecting to 3 other hydrogen atoms. Now, when you have a carbon linking to one carbon atom, this particular carbon will need 3 more hydrogen to complete the 4 bond in which a carbon atom needs to be formed. Now, this particular carbon, a primary carbon, is always found at the terminal. It is always found at the end of an organic molecule. So, second class of carbon atoms that we'll be looking at is a secondary carbon. Now, a secondary carbon is a carbon that is bonding to 2 other carbon atoms. When you have a carbon that is bonding to 2 other carbon, then that carbon is known as a secondary carbon. And this connection makes it possible for the secondary carbon to be connecting to other two hydrogen atoms. So the hydrogen atoms found on a primary carbon are known as primary hydrogen, while the hydrogen that are found on a secondary carbon atom are known as secondary hydrogen atoms. So let's continue. Now, the third class of carbon atom that we'll be looking at is a tertiary carbon atom. This carbon atom, secondary carbon atom, is also known as a 2-degree carbon atom. So a tertiary carbon atom is also known as a 3-degree carbon atom. Now, a tertiary carbon atom is that carbon atom that is bonding to 3 other carbon in a molecule. So this connection makes it possible for the tertiary carbon to have one hydrogen atom attached on it. So this hydrogen atom attached on a tertiary carbon atom is known as a tertiary carbon atom. So lastly, we'll be looking at the fourth class of carbon, which is known as a quaternary carbon atom, also called a 4-degree carbon atom. So a 4-degree carbon atom is that carbon atom that is bonding to 4 other carbon atoms. Now, this connection makes it impossible for this particular carbon atom to be attached, for a hydrogen atom to be attached on this particular carbon. So in the study of organic chemistry, these are the types of carbon atoms that you will come across, especially when it comes to this and this. They are found mostly in branch chains. That is a chain that is not linear but branch. So before we end the class, let's look at one practice question before we end the class. So here is the practice question. The question says, draw the structures of the compound with the molecular formula C5H12 that has 1. Only primary and secondary hydrogens, 2. Only primary hydrogens, and then lastly, primary, secondary, and tertiary hydrogens. Recall that we said primary hydrogens are those hydrogen atoms that are attached on a primary carbon. Same goes to secondary hydrogen, those hydrogen atoms that are attached on a secondary carbon atom. So a tertiary hydrogen is that hydrogen that is attached on a tertiary carbon atom. Now, for us to be able to answer this question directly, we'll first of all understand what that is, which I have just explained. Now, the first question says we should draw the structure that has just primary and secondary hydrogen atoms. Now, the molecular formula of that particular compound is given as C5H12. C5H12. Now, already we know that a primary hydrogen or a primary carbon is always found at the terminal. So, of all those structures, The first is the simplest because now these are our 5 carbon atoms. So this is a hydrogen, this is a primary carbon, and the carbons attached on the primary carbon is known as the primary hydrogens. This is a secondary carbon because it is bonding to 2 other carbon atoms. So for this is what we are going to have as our structure. Now, counting the number of atoms, we have 1, 2, 3, 4, 5 number of carbon atoms, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 number of hydrogen atoms. Now, this structure contains only primary and secondary hydrogen atoms. So, on number 2, we have that we should draw the structure that contains only primary hydrogens. Now, we have 5 carbon atoms. If we take the first carbon atom to be a quaternary carbon, we are going to have 4 carbon atoms at the terminal. Now, these particular carbon atoms are all primary carbon atoms. For that case, the hydrogen atoms bonded on it are all primary hydrogen atoms. Counting the number of hydrogen atoms we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is how you draw a structure with the molecular formula that contains only primary carbon atoms. So lastly, we have to draw the structure that contains primary, secondary, and tertiary. Now, if we draw this, we'll link this. This is a secondary carbon because it is linking to 2 other carbon atoms. So if we want to add 1 more carbon atoms and add here, this will be a tertiary carbon atom because it is bonding to 3 other carbon atoms. So in that case, we'll all just have to link our hydrogen atoms so add 1 more hydrogen here. Counting the number of hydrogen atoms, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is how you tackle a question like this when you come across it in any examination. So if you find this video helpful, please consider liking and subscribing to this channel, because with all this being said, we have come to the end of this video. Please leave a comment so that we will know your views on our videos. Thank you so much for watching.